This is section 5.2, part 2. I'm going to simplify 7 to the third power over 7 to the fourth power. What I have here is I have a fraction with the same base on the top and the bottom. Now I'm going to follow this property directly, exactly the way it says. When you have the same base and you're dividing, you get to subtract your exponents. The base stays the same. So this is going to be 7 raised to the, notice it's the top minus the bottom. So 3 minus 4. 3 minus 4 is -1. So this was property number 9. And now we're not allowed to keep a negative exponent. So I am going to use property number 6. To simplify from here, I probably shouldn't have written it there. It should be here, because that was just arithmetic there. This says it's 1 over our base, which is 7, raised to the now positive 1. And normally we don't write the positive, a positive 1 exponent. It's understood. So this answer is 1/7. Okay. Now another way of thinking about this is if we use, definition of exponents, 7 times itself 3 times, over 7 times itself 4 times, and then we start canceling things out. I have nothing left in the top, so I can always do a times 1 up there, and everything canceled out except the 7 in the bottom, so 1/7. Another way we often think about this, when you have something with the same base and you're supposed to subtract exponents, what we often do is we subtract in the order we would consider normal. Normally, instead of doing 3 minus 4, I would think normal was 4 minus 3. 4 minus 3 is 1, so I'm going to have a 7 to the first power. It's just a question of whether that 7 to the first power is in the top or if it's in the bottom. The 7 is going to be wherever your largest exponent is. So since 4 was larger than 3, my 7 to the first power is going to end up in the bottom. We're going to be talking a lot more about that, so don't worry about that too much yet. Okay, let's simplify 5x to the -3. Okay. Now, the tricky thing here is even after you've worked a lot of these problems, you see a negative exponent, you know it's supposed to be moving one way or the other. People want to move this 5 along with this, but the exponent on the 5 is a +1. A positive exponent's not going to move. Some people think of positive exponents as being happy where they are, and negative exponents are unhappy. So you move the unhappy exponent to the other side, and then they become happy because that's the side they want to be on. It's silly, yes, but it works. So what we have here is the 5, remember this is over 1. The 5 is already happy where it is, so it stays in the top. But this negative exponent is unhappy, so we move it down to the bottom, and the exponent becomes positive. This was property number 6. Okay, similar problem here. We have 1 over 5 to the -2, okay? This time our negative exponent is in the bottom, but if you think of these as being happy or unhappy, you just move it to the other side. So since this is in the bottom and it's unhappy, we're going to move this up to the top. So this simply becomes 5 squared. And this is likely one that they would expect you to probably go ahead and do the arithmetic on. 5 squared is 25. Okay. So let's look here. This time, I have different bases with negative exponents. I have exactly property number 7 right here. 7. Okay, so this is property 7. What this says is that the one that's in the top moves down to the bottom and becomes a positive exponent. So I have 6 squared in the bottom, and then 5 to the 4th moves up to the top. Now this is one where it's a little bit iffy as to whether or not they would want you to go ahead and multiply it all out. If it says to leave your answer in exponential form, this is what they want. You can use your calculator or you could just multiply. 5 to the 4th power is 625. 6 squared is 36.